Imagine looking through one of the world's most powerful telescopes and finding a planet that, according to everything we know about astronomy, simply shouldn't exist. Not because it's too far away, not because it's too large, but because the very star it orbits should have destroyed it billions of years ago. When astronomers first confirmed this strange world, many assumed there had to be a mistake. The data was checked again. The calculations were repeated. Different observatories looked at the same system. Yet every observation pointed to the same impossible conclusion. Somehow, this planet had survived an event that should have erased it forever. And if that's true, then one of our biggest assumptions about how planetary systems live and die may be incomplete. The mystery begins nearly 4,000 light-years from Earth in a star system known as Kepler 1.6. Except this isn't actually the impossible planet. For years, scientists discovered strange worlds that challenged expectations. Planets orbiting two stars, planets with bizarre climates, and gas giants orbiting incredibly close to their suns. Each discovery forced astronomers to rewrite a few lines of their textbooks. But then, they found something even stranger. A planet orbiting the burned-out core of a dead star. At first glance, the star looked ordinary through a telescope, but it wasn't an ordinary star at all. It was a white dwarf. To understand why that's shocking, we need to know what happens when stars like our own sun reach the end of their lives. As these stars run out of nuclear fuel, they expand into enormous red giants. Their outer layers swell outward, growing hundreds of times larger than before. Any nearby planets are expected to be swallowed whole. Mercury would disappear. Venus would vanish. Even Earth may not survive when our own sun reaches this stage, roughly 5 billion years from now. Eventually, the giant star sheds its outer layers, leaving behind only an incredibly dense core. That's the white dwarf. Small, extremely hot, and about the size of Earth, despite containing half the sun's mass. For decades, astronomers believed that any planets orbiting close to such a star would have been destroyed during the violent red giant phase. It seemed inevitable. Case closed. Then, observations began telling a different story. Scientists studying a system called WD 1856 plus 534 noticed something unusual. Every 34 hours, the white dwarf dimmed ever so slightly. The pattern repeated with astonishing precision. Something was passing directly in front of the star. Using NASA's Transiting Exoplanet Survey satellite, better known as TESS, astronomers watched the signal over and over. The transit wasn't random. It was consistent, predictable, real. Further observations using ground-based telescopes confirmed that the object causing the eclipse was enormous, roughly the size of Jupiter. This planet wasn't orbiting far away. It was incredibly close to the white dwarf, closer than Mercury is to our own sun. And that's where everything became confusing. According to standard models of stellar evolution, the expanding red giant should have engulfed that entire orbit long before the white dwarf ever formed. The planet should have been vaporized. There shouldn't be anything left. Yet there it was, moving calmly around the dead star every day and a half. Astronomers weren't just surprised, they were genuinely puzzled. Either the planet had somehow survived one of the most violent transformations a star can experience, or something even stranger had happened. Perhaps the planet wasn't originally there at all. Could it have migrated inward after the star died? If so, what force could move a giant planet across millions of kilometers without tearing it apart? Gravity? Hidden companion stars? Another unseen planet? Every possible explanation raised new questions instead of answering the old ones. Then researchers uncovered another clue buried within the system itself. WD 1856 plus 534 wasn't alone. Far in the distance, two small red dwarf stars quietly orbited the white dwarf. They seemed harmless, but their gravity may have been slowly reshaping the entire planetary system for billions of years. If that idea was correct, the impossible planet might not have survived by luck. It may have been moved into its current orbit long after the star's violent death. But proving such an extraordinary claim would require understanding one of the strangest planetary dances ever proposed in planetary science. And that investigation would reveal an even bigger mystery about how entire solar systems can be rebuilt after destruction.
The idea sounded almost unbelievable. Instead of surviving the red giant phase where it was, astronomers proposed the WD 1856b may have spent most of its life much farther from its parent star. At that safer distance, the expanding red giant wouldn't have reached it. But after the star collapsed into a white dwarf, something remarkable may have happened. Those two distant red dwarf stars weren't simply background objects. Over billions of years, their gravity could have acted like a slow, invisible hand. Astronomers believe a process known as the Kozai-Leadov mechanism may have gradually stretched the giant planet's orbit into an extremely elongated path. With each pass around the white dwarf, the planet came dangerously close before swinging far back into space. At first, the changes were tiny, almost impossible to notice. But gravity doesn't need to work quickly. Given enough time, even the smallest tugs can completely reshape an entire planetary system. As the planet repeatedly skimmed past the white dwarf, powerful tidal forces began stealing energy from its orbit. Like a swinging pendulum that loses momentum, the orbit slowly shrank and became more circular. Eventually, the planet settled into the tight 34-hour orbit astronomers observe today. If this explanation is correct, then the planet didn't cheat death. It escaped it, only to return billions of years later. That realization changed the entire mystery. Scientists had always imagined planetary systems as fairly stable structures. Stars formed, planets settled into predictable orbits. Eventually, the star died, and whatever remained simply stayed where it was. But WD 1856b suggested something far more dynamic. Entire solar systems might continue evolving long after their stars have died. Planets could migrate. Worlds could collide. New orbital arrangements could emerge from what once looked like complete destruction. Then another question appeared. If a giant planet can move inward after its star becomes a white dwarf, could smaller rocky planets do the same? That possibility immediately caught the attention of astronomers searching for life beyond Earth. White dwarfs are faint compared to stars like our Sun. A rocky planet orbiting close to one could, in theory, have temperature suitable for liquid water, provided it arrived after the star's destructive red giant phase. In other words, some worlds may become potentially habitable only after their parent star has already died. It's a strange idea. Life around a dead star. Yet modern astronomy no longer dismisses possibilities simply because they sound unusual. Again and again, the universe has shown that reality is often stranger than imagination. Scientists are now studying many white dwarfs with advanced observatories, searching for additional planets that may have followed similar journeys. Some white dwarfs show evidence of shredded asteroids polluting their atmospheres. Others are surrounded by dusty disks, the leftover debris of broken planetary systems. Together, these discoveries paint a picture of constant change rather than quiet endings. The launch of newer observatories, including the James Webb Telescope, has opened another chapter in this search. Its powerful instruments can analyze the atmospheres of distant exoplanets with unprecedented precision, helping scientists understand how these extraordinary worlds formed and evolved. Future missions may discover entire families of planets orbiting white dwarfs. If that happens, WD 1856b won't be remembered as an odd exception. It may become the first clue to an entirely new class of planetary systems. And perhaps the biggest lesson isn't about one impossible planet at all. It's about the danger of believing we've already figured out the universe. Again and again, astronomers have watched nature ignore the rules humans thought were unbreakable. Planets orbit two suns. Worlds rain molten iron. Black holes awaken after decades of silence. And now, a giant planet circles the burned-out remains of a dead star, where, by every early prediction, nothing should exist. The universe didn't break its own laws. It revealed that our understanding of those laws was incomplete. Somewhere among the hundreds of billions of stars in our galaxy, there may be countless other worlds that seem impossible today, waiting for the next telescope, the next observation, or the next curious scientist to find them. Because in astronomy, every impossible discovery has the habit of becoming tomorrow's accepted reality. And perhaps that's the greatest mystery of all. Not that the universe keeps surprising us, but that it still has so many surprises left